What if I told you the ticking of your clock is lying to you? Not metaphorically, not poetically, physically. For centuries, we've treated time like a river flowing from the past through the present into the future. But modern physics, from Albert Einstein to quantum gravity, whispers something far more unsettling. According to relativity, the now you feel so vividly doesn't actually exist in the fundamental laws of the universe. In fact, in the equations that describe reality, whether it's Einstein's space-time or the strange mathematics behind black holes, time doesn't flow at all. It just is, and in some of our deepest theories, from black hole, thermodynamics to the holographic principle, time may not even be fundamental. It might be something that emerges, like temperature, real, measurable, but not basic. So tonight, we're going to do something radical. We're going to dismantle time, not with philosophy, not with poetry, but with physics. And by the end of this talk, you may realize something deeply disturbing: the future might already exist. The past might still exist, and the present might be the real illusion. Let's begin. You wake up in the morning and feel something undeniable: the present moment. It feels sharp, immediate, alive. The coffee is hot now. The air is cool now. Your thoughts are happening now. It seems obvious that the universe shares this same present with you, that somewhere out there, a giant cosmic clock is ticking in perfect synchronization with your heartbeat. But physics quietly dismantles that comfort. Imagine two observers drifting past one another in empty space. They move at a constant speed, no acceleration, no drama, just smooth motion. Each carries a clock. Each trusts their clock completely. Now imagine two distant lightning strikes hitting opposite ends of a long train track. To one observer, the flashes occur simultaneously, perfectly synchronized. To the other, moving relative to the first, one flash clearly happens before the other. Who is correct? In classical thinking, one of them must be wrong. There must be a true order, a universal now, slicing cleanly across the universe like an invisible blade, separating past from future. But the equations that govern space and time refuse to grant that privilege. Both observers are right. Simultaneity is not absolute. It depends on motion, and this is where the ground begins to shift. If two events that are simultaneous for you are not simultaneous for someone moving differently, then your now does not match theirs. Extend this idea beyond trains and lightning. Extend it to stars, galaxies, entire clusters of galaxies drifting through space at enormous speeds. At this very moment, somewhere in the Andromeda galaxy, events are occurring. But whether those events are happening now depends entirely on your motion relative to Andromeda. Change your speed, even slightly, and your slice of the universe that counts as present tilts. Different events become real for you. Others slip into what you call the past or the future. The present is not a universal layer of reality. It is a perspective effect. Picture spacetime not as a flowing river, but as a vast four-dimensional structure. Every event, the birth of stars, the fall of civilizations, the words you are hearing right now, exists as coordinates within this structure. We experience only a thin cross-section of it, and we label that slice now. But another observer, moving differently, cuts the structure at a different angle. Their slice intersects different events. There is no master slice. This is deeply counterintuitive because evolution wired you to believe in a shared present. Survival depends on coordinated action. If a predator lunges, everyone needs the same now. Our brains constructed a seamless narrative of time flowing uniformly. But the universe is under no obligation to respect neurological convenience. Consider this carefully. If there were a universal present, a cosmic clock ticking everywhere at once, then the laws of physics would need to privilege a special frame of reference, a fixed backdrop against which absolute motion could be measured. But every experiment ever performed shows the opposite. The laws remain identical for all observers moving at constant speed, no preferred frame, no hidden clock embedded in space. Motion changes time itself. Clocks aboard fast-moving spacecraft tick more slowly relative to stationary ones. Particles accelerated near light speed experience time differently. Even gravity alters time's rate. Clocks deeper in a gravitational field tick more slowly than those farther away. Time is elastic, malleable, responsive to motion and mass. Ask yourself, if the rate of time depends on motion and gravity, what anchors the present? Nothing. The idea of a global now dissolves under scrutiny. What you call the present is simply the set of events that are simultaneous with you in your current state of motion. Change that motion and your present changes. Now imagine an observer far away, moving rapidly relative to you. According to their definition of simultaneity, some events you call future are already part of their present. Somewhere, from another legitimate perspective, your tomorrow is already real. This is not philosophy. It's geometry. Space-time can be visualized with axes, 3 of space, 1 of time. An observer's motion determines how these axes tilt relative to one another. The tilt changes which events line up as simultaneous. There is no contradiction, no paradox, just the structure of reality refusing to center itself around human intuition. And here's the unsettling implication. If the present is not universal, then the distinction between past, present, and future is not written into the fabric of the cosmos. It is written into your trajectory through it. You are tracing a path, a world line, through space-time. Along that path, your brain continuously updates sensory data, encoding memories of states behind you and anticipating states ahead. This process gives the sensation of a moving present, but the equations describe a static structure in which all events coexist. The feeling of flow is not in the mathematics, what you experience as becoming. The unfolding of reality does not appear in the fundamental description. Instead, there are events laid out in space-time, related by causal structure and light cones. Your perception stitches them into continuity. Light plays a crucial role here. Because information cannot travel faster than light, each observer has a limited causal horizon. Your present contains only events from which light has had time to reach you. But this limitation is about information exchange, not about existence. Events beyond your light cone are not unreal, they are simply inaccessible. The absence of a universal now means that reality is not updating itself moment by moment. There is no cosmic processor rendering frames sequentially. The universe is more like a completed landscape than a story being written in real time. Pause and let that settle. If simultaneity depends on motion, if motion alters time, if no preferred frame exists, then the present is not a property of the universe as a whole. It is a relational concept defined locally, dependent on perspective. Your now is valid, so is someone else's, even if they disagree. Reality does not choose between them, and that is where the illusion cracks open. What feels like the most immediate, undeniable aspect of existence, the living edge between past and future, turns out to be a feature of how observers slice space-time, not a fundamental layer of reality itself. Imagine a film reel stretched out across a long table. Every frame is already printed, the opening scene, the climax, the final image. When you watch the movie in a theater, the projector feeds those frames one by one through a beam of light, creating the illusion of motion, of unfolding, of becoming. But the story does not come into existence as you watch it. It already exists in its entirety on the reel. Now replace the film with the universe. In the deepest description offered by modern physics, reality resembles not a story being written, but a completed structure. Not a river flowing, but a landscape simply there. Every event that ever occurred, every event that will occur, is embedded within a four-dimensional geometry called spacetime. 3 dimensions of space, 1 dimension of time, woven together into a single fabric. You move through space freely, forward, backward, left, right. But you feel time differently. You feel carried along it as though it is pushing you. Yet the equations that describe the structure of spacetime do not contain a moving present. They do not describe a cosmic spotlight sweeping across existence. They describe a fixed geometry. Think of the entire history of the universe, from the first fusion in early stars to the last fading photons in the far future, laid out as points in this structure. Each event is a coordinate, not waiting to happen, not dissolving into nothing, just part of the whole. This view is sometimes called the block universe. A block not in the sense of something small or rigid, but in the sense of completeness. All of spacetime forms a single entity. Past and future are not vanishing and emerging. They are regions. Close your eyes and imagine Earth not as a sphere frozen at a moment, but as a four-dimensional worm stretching from its fiery formation to its final cold silence. Every rotation, every season, every birth and extinction, all contained within this extended structure. Your life, too, is not a flicker appearing and disappearing. It is a world line, a continuous thread woven through space-time from your first breath to your last. You do not pop into existence and then vanish. Your existence is a segment within the total geometry. This does not mean change is unreal. Change is encoded as differences between neighboring regions along your world line. But the entire sequence exists. Just as the beginning and end of a mountain trail both exist, even if a hiker experiences them step by step. The discomfort comes from language. We say the past is gone and the future does not yet exist, but physics does not grant that asymmetry. If the present is not universal, if different observers carve up spacetime differently, then singling out one moment as ontologically special becomes impossible. From one frame of reference, a distant event is in your future. From another equally valid frame, that same event is already present. The structure must therefore accommodate both. The simplest way to do so is to treat all events as equally real. In this picture, the universe is not evolving, it is. Your sense of unfolding is tied to consciousness, tracing a path through this block. At each point along your world line, your brain holds records, memories of other points labeled earlier. It lacks records of points labeled later. That asymmetry gives rise to anticipation and recollection, but the asymmetry is local and experiential, not embedded in the global structure. Picture a long novel printed in a single volume. A reader begins at page 1 and advances sequentially. The characters seem to grow, change, struggle toward unknown outcomes, but from the perspective of the book itself, all chapters coexist. The final page is not less real than the first. The drama lies in the limited access of the reader. The block universe view suggests you are like that reader, moving across pre-existing pages. Now consider the implications. Somewhere in that four-dimensional expanse lies the moment you will learn something profound. Somewhere else lies your final conversation, already etched into the fabric. These moments are not floating in a void waiting to crystallize. They are coordinates in space-time. This does not imply fatalism in a simplistic sense. Within the structure, your decisions are part of the fabric. Your choices are not imposed externally. They are elements of your world line. The geometry includes them. From within your perspective, deliberation feels open because you do not have epistemic access to future segments. But lack of access is not lack of existence. The mathematics that describe gravitation do not contain a ticking parameter pushing the universe forward. They describe relationships between events. Geometry replaces flow. Curvature replaces force. The entire manifold of spacetime satisfies the equations as a whole. There is no universal updating rule applied moment after moment. Instead, the structure simply conforms to the constraints given by physical law. The cosmos is less like software running in real time and more like a sculpture, intricate, complete, internally consistent. It feels alien because consciousness evolved to process sequences. Neural activity unfolds in ordered patterns. Memory accumulates, prediction projects. That internal sequencing gets mistaken for a property of external reality. But the deeper description suggests the sequencing belongs to you. Stand on a mountain and look at a valley. You see the river twisting below, but from your vantage point you apprehend its entire visible length at once. The water flowing at one bend does not erase the water downstream. They are different locations in space. In the block universe, moments are like bends in a river that is not flowing through time but extended along it. Another metaphor, imagine space-time as a vast crystal. Each event is an atom in the lattice. The crystal does not grow layer by layer in some external time dimension. It simply is a configuration. Observers embedded within it perceive trajectories through that configuration as the passage of time. The unease arises because this vision challenges the cherished intuition that the future is open and the past fixed. In the block perspective, both are fixed as parts of the whole. Openness becomes a statement about knowledge, not about ontology. And yet, nothing in your daily experience contradicts this once you reinterpret it. You still strive, decide, fear, hope. Those experiences are real features of segments along your world line. Their reality does not depend on future segments being non-existent. It depends on how information flows within the structure. If all events exist in the block, then the difference between yesterday and tomorrow is not existence versus non-existence. It is location. You are not being carried by time toward an uncertain void. You are traversing a dimension much like space, though experienced differently. The past is not obliterated. It is simply elsewhere in the structure. The future is not a blank canvas. It is another region you have not yet encountered. The profound shift is this. Time may not be something that happens. It may be something that is. You feel time moving in one direction. You remember yesterday, but not tomorrow. You can break a glass, but you never see shards leap from the floor and reassemble themselves into a perfect cup. There is an unmistakable asymmetry built into your experience, a forward tilt to reality. We call it the arrow of time. But here is the unsettling truth. The fundamental laws governing the motion of particles do not care about that arrow. At the microscopic level, the equations that describe motion, whether for atoms, electrons, or planets, work just as well if you replace time t with t. Run the math forward, run it backward, the equations remain valid. A collision between two particles looks entirely plausible when played in reverse. The laws have no built-in preference for before, over, after. So where does the direction come from? To approach this, picture a simple box divided into two compartments by a thin wall. On one side, a gas is compressed. On the other, there is vacuum. Remove the wall. Instantly, the gas spreads out to fill the entire box. The molecules move randomly, colliding, dispersing, distributing themselves evenly. Now imagine watching a recording of that process. Gas expanding feels natural. But if you reverse the video and see randomly dispersed molecules suddenly gather into one corner, compressing themselves neatly without external influence, you immediately sense something impossible. The microscopic laws do not forbid that reversed motion. Every individual molecular trajectory in the reversed video obeys Newtonian mechanics. So why does it look absurd? The answer is entropy. Entropy is not about disorder in a casual sense. It is a measure of how many microscopic configurations correspond to the same macroscopic description. A tightly compressed gas has relatively few microscopic arrangements that fit all particles in one corner. A uniformly spread gas has an enormous number of possible microscopic arrangements that look the same at large scale. Systems evolve from less probable states to more probable ones simply because there are vastly more ways to be spread out than concentrated. The arrow of time is born not from the laws of motion, but from statistics. The universe began in a condition of extraordinarily low entropy, a state of astonishing order. That fact is not obvious at first glance, because the early universe was hot and dense. But uniformity at cosmic scale represents low gravitational entropy. Matter was evenly distributed, not clumped into stars and galaxies. As gravity amplified tiny fluctuations, structure formed. Entropy increased. From that initial condition forward, entropy has been climbing. This increase creates gradients, hot to cold, concentrated to diffuse, ordered to scrambled. Those gradients make processes irreversible at the macroscopic level. Ice cubes melt. Stars burn hydrogen into helium. Living organisms consume energy and radiate heat. All of it rides the slope of increasing entropy, but notice something subtle. The direction is defined by boundary conditions, not by the core equations. If you were to take every particle in the universe right now and reverse its velocity perfectly, an unimaginably precise operation, the system would evolve backward toward lower entropy. Shattered glass would reassemble, smoke would contract into flame, memories would unravel into anticipation. The laws would allow it. We never observe such reversal not because it is prohibited, but because it is fantastically improbable. The higher entropy configurations so vastly outnumber lower entropy ones that spontaneous large scale decreases are practically impossible. Probability sculpts our sense of time's direction. You experience the arrow of time because your brain depends on entropy gradients. Memory formation involves physical processes, chemical changes in neurons that increase entropy overall. To remember yesterday means your brain encoded information using energy, dissipating heat into the environment. The act of remembering embeds you within the forward statistical flow. Memory points toward lower entropy states because those states left imprints as entropy increased. You cannot remember tomorrow because those microscopic configurations have not yet generated records along your world line. The asymmetry of memory is not a metaphysical fact. It is thermodynamic bookkeeping. Consider again the microscopic view. If you isolate two atoms colliding in deep space, there is no intrinsic label marking which direction of time is correct. The collision is symmetric. Only when you zoom out to trillions upon trillions of particles do statistical imbalances dominate perception. You live at the macroscopic level. Your senses average over unimaginable numbers of particles. In that averaging, probabilities overwhelm reversibility. Time emerges as a one-way street. Yet the deeper story whispers something radical. The arrow is not fundamental. It arises because the universe started in a very special, very low entropy configuration. Had it begun in equilibrium maximum entropy, nothing interesting would happen. No stars, no chemistry, no life, no observers to ask questions. Entropy gradients would not exist to fuel complexity. The fact that you are here contemplating time already implies that the cosmos had an arrow. But this arrow is contextual. It depends on global boundary conditions, not on local laws. Change the boundary conditions and the arrow could flip. Imagine a hypothetical universe contracting toward a final low entropy state. In that scenario, beings embedded within it might experience what we would label a reversed arrow. Their memories would align with increasing entropy in their direction. From their perspective, we would seem inverted. This possibility illustrates that forward is not etched into the equations. The thermodynamic arrow also gives rise to causality as we perceive it. Causes precede effects because entropy increases toward what we call the future. A broken cup increases entropy compared to an intact cup. Therefore, we interpret intact as cause and broken as effect. But fundamentally, the chain of events is a sequence linked by physical law without preferred temporal orientation. The sensation of time flowing is tied to irreversibility at scale. Look deeper still. Even entropy increase can be understood statistically within a larger structure that may itself be static, a vast space-time in which entropy gradients are encoded geometrically. In that view, the increase is a feature of how different slices of space-time compare, not a dynamic process pushing the universe along. What you feel as the current of time may be the experience of moving through regions of differing entropy within a four-dimensional whole. The arrow is real in experience, but derivative in explanation. It is like the direction of a coastline's slope. Stand on the sand and you feel gravity pulling you downhill. But gravity itself is not a preference of the sand. It is part of a larger geometric structure. Similarly, time's direction is the slope carved by entropy conditions within the architecture of spacetime. You measure time with clocks, but clocks are physical systems subject to entropy. They tick by converting energy in irreversible processes. Every tick increases disorder somewhere. The act of measuring time depends on the very asymmetry it reveals. So the next time you sense the future approaching, remember that nothing in the microscopic script demands that direction. It is statistical weight, rooted in cosmic initial conditions, that biases events toward what you call forward. The universe does not fundamentally know which way is ahead. It simply unfolds probabilities across an immense tapestry of configurations.